What is a category rated cable? What is the difference between Cat 5 little e and Cat 5 big E, as well as all those other categories? That is the subject of today's show.
Don't hang up that phone. We've found what you're looking for. Welcome to the Let's Talk Cabling podcast with Chuck Bowser, RCDD. What exactly does RCDD stand for? Registered Communications Distribution Designer. Just the expert you need to ensure your cable plant performs exactly as designed. Now, send the new guy to the truck for a bucket of dial tone and the cable stretchers, while you listen to an informative program on telecommunications.
Welcome to the show where we tackle the tough questions submitted by IT personnel, estimators, installers, and customers. On this show, we connect at the human level so that we can connect the world. If you are watching this podcast on YouTube, would you mind hitting the subscribe button and the bell button to be notified when new content is being created? If you're listening to this podcast on iTunes or one of the other podcast platforms, would you mind leaving us a 5-star rating? These couple little steps helps us take on the algorithm so we can get the message out to more people in the ICT industry to help us educate, encourage, and enrich the lives of people who are trying to do this kind of work. Also, don't forget our After Hours live series broadcast Thursday nights, 6 p.m. Eastern Standard Time, where you could submit your questions to be answered by your favorite RCDD, that would be me, live on LinkedIn, YouTube, and Facebook. If you missed the live broadcast, they are recorded for later consumption. Make sure you submit your questions early to questions@letstalkcabling.com. Submitted questions get preference. Also, make sure to check out our webpage where you can find all of our recorded podcasts, vlogs, and articles. You can also sign up for our newsletter and also ways to help support this learning platform like Patreon, Amazon links, and donations through PayPal. This show is free and will always remain free. I had an interesting exchange of comments on TikTok recently. I had watched a video of an electrician explaining how to terminate Category 5 cable. It was a good video, but I posted that the ANSI standard does not recognize Cat 5 cable anymore, and the minimum rated category cabling allowed for new installs is Category 5E. I had no idea that was going to blow up. I did that because many installers will refer to any category rated cable as Cat 5 cable. Words have specific meanings, and to ensure that there are no miscommunications, you need to select your words carefully when using them or interpreting them from an RFP, scope of work, or giving instructions to your crews. This could lead to a misunderstanding that could cost you time and money, both of which we have very limited quantities of. So this got me to thinking that most people don't know the history of category-rated cabling. Now, I have a unique view on this as my career spanned across the majority of this. Carol Everett Oliver, RCDD ESS, our incoming, current, or past president of Bixby, depending on when you're listening to this show, wrote a great article on this subject back in January of 2013. The article of that was called "The Cat's Out of the Bag." So first, let's talk about standards. If you're doing work in Canada, the US, or Mexico, you're generally going to be following the ANSI standards. Outside of the US, you're going to be following either the ANSI or the ISO 11801 standards. Now, while those standards are similar, there are differences between those two. Now, keep in mind, you need to know which area the standards that you're going to be following. Following the standards will guarantee the customer's network will perform as designed, to be interoperable, to work with any type of networks, and to work consistently. This is the reason for the 90 meters or 295-foot length for permanent link cables. As long as we use a rated cable for the network we are installing and stay within that length, it will work consistently. Sometimes you will find certifications for partial lengths, and we'll talk more about that later. Standards are also voluntary, which causes much confusion in our industry. However, you should always follow the standards, and if the customer tries to go away from the standards, you need to talk to them into following the standards because it will guarantee that performance, interoperability, and consistency. When I first got in the ICT industry back in 1982, I worked for a small company in Northern Virginia called Custom Computer Cable. We specialized in data cabling like twin-ax, coax, type 1, just to name a few. Then the telephone company would come out and install the voice cabling and also the telephone switch. My father-in-law was an employee of AT&T and a premise technician. The primary cable that was installed was JK cabling or Jake cabling. They would also refer to this as station cable, inside wire, POTS cabling, which stood for plain old telephone service, or sometimes quad wire. I don't know the original designation of what JK actually meant. If you happen to know, put it in the comments so we can educate people. So the quad cable that I worked with had 4 conductors inside of it. Those conductors were red, green, yellow, and black. If you look at some of the older style phone jacks, you'll see exactly those colors on the back. I just did a TikTok about one of those old ones. You would just basically strip the wire, strip the dielectric off the wire with a notch on your snips, wrap it around the screw terminal, tighten it down, and then snip off the excess conductor. That quad wire could support up to 64 kilobits per second with a rating of 64 kilohertz to support phone lines. It could also support some limited data applications, such as RS-232. Then 2 important things happened in our industry that changed everything. One was divestiture. The other was computer companies realized that their systems could operate over twisted pair cabling. Now, this change didn't happen overnight, but it did happen pretty quickly. And this would also bring efficiencies because the proprietary cable plant that they used to have to install just couldn't offer that kind of change. When the customer would purchase their computer or terminals, they generally had to also buy a specific proprietary type of cable to operate that network over. Now, we all know in the ICT industry that our industry changes at the speed of light, both literally and figuratively. There's always some new computer, some new operating system that would often require a customer to change out their computers or the terminals and go to maybe even a different manufacturer. So when they would upgrade to that different manufacturer, they would have to exchange the computers and the terminals and also have to change the cable type because of that proprietary type of cable plant. The old cable plant might have been type 1, but the new one might have been something else. By changing over to UTP or shielded twisted pair cabling, it standardized everything and made those transitions a lot simpler for the customer because now the cable plant worked with any manufacturer, any computer network, any mainframe, any terminal. They didn't have to replace the cable. All they had to do was replace the equipment. At about that same time all this was happening, Anixter developed their Levels program, which was developed at the 1989 Bixby Winter Conference. Now, Level 1 was for analog phone lines. Level 2 was for IBM cabling and designated to support 1 to 2 megabit networks. And Level 3 was for 10BASE-T and token ring. This helped customers and their sales force to quickly and accurately determine the correct cable and connectivity products for the requirements of the network that they were trying to install. This system of identifying cables was later adopted by UL. It was a very confusing time to be an installer in the ICT industry. So the industry desires neutrality when it comes to placing the cable plant because it's harder to replace the cable in an existing office space. When the customer's going to a new computer system in an existing office space, then you got to work over people, desks, and furniture. So when a customer upgrades that new network, it's always better if they only have to change just the equipment. This is where the ANSI standards are a little different as they didn't formally recognize the number 1 and number 2 levels like the ISO did. ISO doesn't use categories, rather they call theirs classifications. So Class A was recognized for the 1 kilohertz using Category 1 cable and connectivity products. Class B would support 1 megahertz using Category 2 cable and connectivity. And that's the way the system works. The higher the number, the better performing the cable is. Each new level should be backwards compatible with the previous versions of the cable plant. So Cat 5e cable should be able to work with a Category 3 cable. Cat 3 should be able to work for Category 2 or Category 1, or Class 2 or Class 1. The first category rated UTP cable to really take hold in ANSI was Category 3, ISO Class C. This cable can support transmission speeds up to 10 megabits and has a performance of 16 megahertz. Now remember, this would cause a lot of confusion because most installers back then didn't know the difference between megabits and megahertz. If you go back into my podcast feed, one of my earliest shows, I covered this in great detail. But to surmise, and using a parable, megahertz is like the highway. Think of it as having 10 lanes. The 10 megahertz has 10 lanes. Megabits is the traffic. It's the cars, the trucks, the buses that are going down that highway. The more lanes you have on the highway, the more traffic it can handle. There are other ways as well to increase how much data you can put down a cable using different encoding schemes, but that was covered in that previous show that I mentioned in great detail. So go back and listen to that show. Then came along Category 4 cable. Category 4 cable disappeared as fast as it came to the market. I only installed one Category 4 cable plant in my entire career. Category 4 cable was the UTP replacement for token ring networks and had a transmission speed up to 16 megabits. I could not find any direct crossover for Category 4 cable to the ISO 11801. So if you happen to know what it is, make sure you shoot me an email or post it in the comment of this video. Then came Cat 5 cable. It showed up in the ANSI standards in 1995. Now most of the people believe that the category rating was limited to just horizontal cabling. However, you could purchase Category 5 25 pair cable or multi-pair cabling. So it was available in more than just horizontal cabling. So this was all about the time when computer networks, or personal computer networks, were really starting to take off, and people were heavily investing in personal computer networks and putting them in their homes. They heard about this Category 5 cable that works with Ethernet, and the common for many years was to install a duplex faceplate, Cat 3 for voice and Cat 5 for data. Later, we changed it to Cat 5e per the standards. This is also where much of the confusion comes in when it comes with Cat 5 and Cat 5e. Now, many installers, or those less informed, will call a Category 5e cable Cat 5, basically mislabeling it. There is a difference between Cat 5 cabling and Cat 5e cabling. It depends on what the cable was designed and certified for, and what could actually work on that cable. Keeping in mind that people who created the standards want the standards to work consistently. They want the network to have a maximum run length of 90 meters or 295 feet for the permanent link. And we can get into later discussion on how they actually came up with that number. And sometimes higher speed networks may work on lower performing cables, but sometimes at a reduced length. Sometimes even a significant reduction of length. That's why you hear some people say Cat 5 can support 1 gig, extremely short distances. And it also may not work consistently. Remember, that's what the standard wants. It wants it to be consistent. To add another layer to all this confusion, this is sometimes called, the manufacturers come up with the cable on their own identifiers to show that their cable is better than the one that performs with the standards. For example, Category 5 lowercase e and Category 5 uppercase e. I always get questions about the difference between those two cables. In the standards, there's only one Cat 5e, and it's rated up to 100 megahertz. The manufacturers who come out with the Cat 5 Big E state that their cable can perform beyond 100 megahertz, some of them up to 350 megahertz. And that 295 feet, making the cable, like I said earlier, sometimes they can go past that, making their cable better than the competition, but it's still not a standard compliant cable. This caused a lot of confusion within our industry. It's still a Category 5e cable. The tester is only going to test it to 100 megahertz unless you make some changes. So as many installers will tell you, Category 5e cable became the workhorse that we used for a long time. It debuted in 2001. It is now, as of this recording, the minimum grade twisted pair cabling to be used for horizontal cabling for both voice and data applications per the ANSI standards. Cat 5e cable can support the same networks as Category 5, but it was now also certified to handle 1 gig networks up to 55 meters or 180 feet reliably. They did this by changing the twist rates within the cables. Increasing the twist rates reduces the effects of crosstalk between the pairs, which allows that cable to perform better and allow that 1 gig network to function. For a long time, this is the cable that was selected for most home networks because they moved away from Cat5 and they went to Cat5e. Not far after that Cat5e was accepted by the industry, we came out with Cat6 cabling. Cat6 cabling was constructed in a manner that the performance level was increased up to 250 megahertz. Remember the discussion we had earlier? The more lanes on the highway, the more traffic it can handle. Well, this has 150 more lanes than that 100 megahertz does. Now, this will give you a guaranteed performance of up to 1 gig for up to 90 meters or 295 feet. Cat6 cable could also reliably handle 10 gig networks, but only to that reduced 55 meter mark. This is quickly becoming a favorite for residential applications, replacing Cat5e. As you know, network capabilities keep increasing. So because of that, now comes Category 6A. Cat 6A, the A stands for augmented, and it has a performance rating of up to 500 megahertz, and it can support that 10 gig network up to the full 90 meters or 295 feet. The most common Cat 6A cable was shielded when it first came out, and then it came out with a discontinuous shielded wrap, and now you can also get Cat 6A UTP. Cat 6A cable can have a large outside diameter up to 0.357 of an inch, which is a formidable challenge to install within the bend radiuses and the stiffness and the twist rates. There are some reduced outside diameter Category 6A cabling, which can be as small as 0.25, which is nearly the same OD as a Category 5E cable. Sometimes, though, that reduced outside diameter cost will cost you the available length that cable can run and still maintain 10 gig. Some can do it, some can't. So when choosing a reduced outside diameter Category 6A cable, pay really close attention to the manufacturer's specifications to make sure that you are giving the customer the performance that they want. Then things got interesting. Category 7 and Category 7A. Now, ANSI has not adopted either of these two categories of cables, and I'm not entirely sure why, as I don't serve on those committees. However, they were adopted by the ISO 11801 standard. Remember I told you the standards were different? This is one of those areas. Category 7 cable can still handle 10 gig on the network, but they increased the bandwidth up to 600 megahertz. So you still get the same performance as the Cat 6A. They also did this by adding some additional shielding. So Cat 7 cable can be terminated on an APHC or a Terra connector. Then came Cat 7A. Still capable of 10 gigabits, but has a bandwidth up to 1.2 gigahertz. As I mentioned, in the US, we don't typically install Cat 7 or Cat 7A, but often it's used in areas outside of the US. Inside the US, if you get asked to install Cat 7 cable, your customer probably has offices outside of the US. Then came Cat 8 cabling. Category 8 cabling was designed for the additional bandwidth required to be used in data centers. Cat 8 can handle up to 40 gig networks at a bandwidth of 2 gigahertz. This kind of performance comes at a cost, however. This is only rated to go a maximum of 30 meters or 98 feet. I recently saw some comments on TikTok, people talking about running cabling for their personal networks in their house, and several of them said that they were going to install Category 8 cable for their residential network. But very few people can afford the electronics required to achieve that level, so it was really kind of a waste. Stick with Cat 6 or Cat 6A. One last thing about category rated cable and connectivity products. They all must match, meaning if you want the performance of a Category 6A system, all of the components have to be Cat 6A. The connectors, the cable, the patch panels, and the patch cords. If you use Category 6 or Category 5E parts, you reduce the ability of that network to its lowest performance rating. Also, there's a huge gray area around what networks will work on which type of cable plant, and if they can actually go further than the allowed 90 meters or 295 feet. As I mentioned earlier, when it comes to twisted pair cabling, the shorter the run, the more bandwidth it can actually handle. The full length is mandated by the standards is because consistency and performance. One method to determine what will actually work is to test the cable plant with a BERT tester. I'll do another show on BERT testers later on to explain exactly what this process is. So I hope I was able to shed some light on this confusing rating of cables, and you'll be able to use this information to help plan design, or install certifying your network. So until next episode, remember, knowledge is power.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.